Vector Calculus MAT560, applying a line integral to solve a real-world problem. Prepared for Dr. Nur Atika binti Salahuddin.
Starting off with the introduction, in calculus and vector analysis, a line integral extends the concept of defining integration from single variable function to vector field along a curve in space, measuring the cumulative impact of a vector field along a specified path. Mathematically, the line integral of a vector field f along a curve C is written as integral f dot dr, where the dot product f dot dr represents the interaction between the vector field and the tangent vector dr at each point on the curve. Evaluating this dot product along the curve and integrating with respect to a parameter t, we get integral ab f rt dot r prime t dt, where r prime t is the derivative of rt. Line integrals are used in physics, engineering, and mathematics to represent work done by a force along a path, circulation of a vector field around a loop, and flux of a vector field through a curve.
For the situation 1, the question asks to calculate the work done by a force field on a robot moving along a specific path in a factory. The path consists of two straight line segments and the force field is given by F xyz equal to 2x 3yz. This solution involves using the concept of line integral, which is typically covered in chapter 2 of vector calculus. Line integrals allow us to calculate the work done by a force field along a specific path. So here is the step on how to calculate the total work done from the question. First, we parameterize the path for each segment by substituting the initial and terminal points into the formula. Segment 1 goes from the coordinate A, 0, 0, 1 to B, 3, 4, 1, and segment 2 is from coordinate B, 3, 4, 1 to C, 6, 4, 1. Secondly, set up parametric form and transform into vector equation. For each segment, we now have the parametric equation. Next, we need to find the derivative of these parametric equations to get the differential path elements. And we get r prime t, which is 3, 4, and 0 for segment 1, while 3, 0, and 0 for segment 2. For step 4, we will use the formula for the line integral of a vector field along a path rt, which is the integration of f rt and r prime t. In this step, we evaluate the force field along rt, find the dot product of f and r prime t, and last but not least, we need to integrate over the interval. This step is applied to each segment to obtain the work done. Lastly, the total work done by the force field along both segments is the sum of the work done along each segment that we calculate in step 4. The total work done by the force field Fxyz equal to 2x 3yz on the robot as it moves along the specific path is 60 units.
Hello, today I'm going to talk through the process of computing a line integral for vector field using maple command for situation 1. First, we define our points. Here we have 3 points, the origin 0, 0, 1, the midpoint 3, 4, 1, and the endpoint 6, 4, 1. Using the space curve function, we create the line in segment connecting this point. Finally, we use the display function to render our 3D plots. Here's the maple command to do this graph. First, we declare all the initial and terminal points for both segments. For segment 1, we have the points defined as follows: AT equal to 3t, BT equal to 4t, and CT equal to 1. For segment 2, the points are XT equal to 3 plus 3t, YT equal to 4, and ZT equal to 1. This parameterization sets the stage for our line integral calculations. Next, let's compute the line integral for segment 1. We begin by initializing the vector calculus package with vector calculus. Then we define our position vector r. Then, the differential vector m is obtained by differentiating r with respect to t. Define the r into the function f equal to 2a, 3b, and c. Then we compute the integral p equal to f times with m dt and resulting in p equal to 3, 3. For segment 2, we follow a similar procedure. We define f and differentiate it in the term of t and set up the function of a equal to 2x, 3y, and z and compute the integral I for a times m dt and resulting, which is 27. Finally, we add the integral for both segments to get the total line integral. Thus, the final answer is p plus I is equal to 60.
For situation 2, the scene takes place at a cutting-edge research facility where scientists are developing an advanced MRI machine with a complex 3-dimensional electric field given by an equation E xyz is equal to 3yx squared plus c. They are studying a proton's motion following the helical path rt is equal to cos t sin t and t, where the limits are from 0 to 2 pi. To calculate the work done by the electric field on the proton along this path, they use the line integral W is equal to integral C dot dr. This research aims to optimize MRI performance and safety. For the manual calculation, firstly we have to differentiate the given function rt is equal to cos t as x, sin t as y, and t as z. And we will get r prime t is equal to negative sin t, cos t, and 1. Then we move on to the second step, which we want to find the differential arc length by calculating the norm of r prime t just now, and the answer will be square root 2. Let's set up and evaluate the integral. As you can see here, we just set it to the value of x, y, and z into the equation. We let cos t as u and differentiate it so that we can eliminate sin t in the equation and proceed with the next evaluation until we get the final answer after we integrate the whole equation and substitute it with the value of limits, which are 0 and 2 pi. After all these steps, you will get 2 square root 2 pi square units or 27.9155 units as the final answer for this problem.
Moving on to Maple command for situation 2. Firstly, we plot the graph. As you can see here is the output of the graph after we plot them using Maple. Next is we do the calculation. First of all, we must declare the function rt, which is cos t, sin t, and t. Then we differentiate them. Secondly, we must find the differential arc length using norm underscore dr equals to norm dr will produce an output of square root 2. Next, set up and evaluate the integral by stating the equation of 3y dot x squared plus z, and we will get the final answer of 2 square root 2 pi square, which is equals to 27.9155.
For the conclusion, in situation 1 for the warehouse robot moving along the predefined path from point A to the storage area C, the total work done by the force field Fxyz is equal to 2x, 3y, and z was determined by evaluating the line integral of the force field along the robot's path. This calculation involved dividing the path to two segments from A to B and B to C and integrating the force field along these segments. The total work done by the force field on the robot was found to be 60 units. This result highlights the significant influence of the force field on the robot's movement, which could be crucial for optimizing the robot's path and energy efficiency in the warehouse environment. In situation 2, in the case of the proton moving through the MRI machine's electric field, Exyz is equal to 3ys squared plus z along a helical path, which is the line integral concept. The work done by the electric field was evaluated by integrating the field along the proton's parametric trajectory. The calculated work done was approximately 27.9155 units. This quantification is essential for understanding the energy changes experienced by the proton, which impacts the imaging resolution and safety of the MRI machine. Accurate computation of the work done helps in refining the design and operation of advanced MRI systems, ensuring better imaging quality and patient safety. Overall, this calculation demonstrates the importance of understanding the interaction between moving objects and force or electric fields in various applications, whether optimizing robotic movements in a warehouse or improving the functionality of advanced medical equipment. Precise mathematical analysis of work done by fields is crucial for enhancing performance and efficiency. Thank you and Assalamualaikum.